Hey everyone, welcome to this session of Global Hack Week featuring Data Week, I believe so. For today, we're going to be seeing MongoDB vector search indexes, and I actually have some interesting stuff related to new launches from MongoDB, specifically the Voyage AI API and some other different things on the RAG pipelines. Because MongoDB has become a really popular non-relational database, and by now they're basically shifting into AI tools. And they recently added a new update on their vector search indexes pairing up with Voyage AI. So, no worries if you have no idea what I'm talking about. We'll be going step by step into understanding each one of these tools. I'll actually be using some of the content that we've seen on previous streams that I've done on vector index searches and embedding models, as well as building RAG chatbots, in order to put everything summarized really nicely so we can actually test these tools. Because testing these MongoDB tools is a bit simple. It's just running a couple scripts, but understanding what's behind it and how it works, that's more work that we need to do in order to understand it. So don't forget to check in into the stream. I placed a small QR code on the top left corner where you can check in, so you can get your points for the weekend. And then I also sent out the direct link on the chat in case you want to see it from there. Remember to check in so you can, get your points for attending each of our streams. Right. So let us begin then. So my name is Jocelyn. I believe I've introduced myself at previous streams. This is my first time on Data Week. I was present on the last Global Hack Week with a couple streams. Just because I've been assigned to many hackathon events, I've been traveling a lot, so maybe not a lot of time to do streams. But I'm always happy to do at least one or two streams per Global Hack Week, so I can see you all. As I said, my name is Jocelyn. I'm a coach here at Major League Hacking. Some of my fun facts is that I like salsa dancing, and I also collect Minecraft plushies, which is really nice. I'm still studying, and I study robotics. I'm based in Mexico, and yeah, I guess that's something about myself. If you have any questions about anything, also the MLH fellowship, because I was also a previous fellow in there, and I'm just working with part of the fellowship team. And I'm also a GitHub Campus expert, which is also important if you want to do events at your communities. So you can also ask me questions about that, or also as an MLH coach. Anything. So this is our agenda for today. We're going to be getting an introduction to vectors, and we're going to get understanding what RAG is. We're going to be building a vector index search or learning how to do it. Because at the end, I want us to build a sample project with Voyage AI, which will be basically following along the documentation page and seeing how it translates with MongoDB as well. So my goal after this session is that you will understand how to create a RAG retrieval system and connect that with MongoDB. So for those of you who already know what RAG is, what vector embeddings are, and how to connect that with MongoDB, you will know that there's many things and there's different embedding models that you can use in MongoDB. And at the end, MongoDB is just a database that you can use in order to store all of these embeddings that you're going to be using for your RAG system. This is very important if you are wanting to learn more about LLMs and build, more concrete applications, not just connecting to a regular API, but also adding a bit of context to your prompt, so you can have both your LLM and then also context on what you're doing. So now when you go to your next hackathon, you can add a special something, because we do love to see RAG applications when we are judging MLH sponsored prices, because it adds another layer of creativity and also complexity on your regular projects. Hey there, yes, it's me. I'm back for Data Week. I'm only gonna be giving this stream just because I'm being really busy with a lot of things. But I prepared this stream with a lot of love and also a lot of new tools from MongoDB that MLH wants to showcase to hackers. So yeah, here I am. Right, so I'm gonna be skipping this one and jumping directly into embeddings, because I believe at this point everyone knows what an LLM is, or at least they have used once in their lifetime, especially to the target audience that we are having right now during this stream, or if anyone will watch this recording later on. So for embeddings, it's basically converting what you have a sentence into numbers. That's just a super simple and broad definition of it. And we can see this diagram that basically represents the pipeline for converting your text into embeddings, which is basically what your LLM does when you are asking a prompt or any question to your regular to your choice LLM. So you have your sentence, and then you have your embedding model, and then that embedding model is converted into a vector, and then that vector can be represented into a space. So that space plots, you can basically plot things because you have a vector, and you are plotting that onto a space. And we can see how different words, well, different sentences relate semantically depending on what the sentence is about. So, for example, boy is walking and girl is walking are close to each other because they're similar. And then the I am studying, it's just farther away because it's not really directly related to the other two sentences. So, embeddings is just basically converting your text into numbers, so you can then play around with those numbers, and we will see all of the different things that we can extract from those set of numbers is actually what LLMs do when you ask them a prompt. So again, this is another example. We also need to be familiar with the word tokens. Tokenization, which comes from tokens, is basically breaking down into smaller units called tokens, such as words, characters, or subwords. So in order to be able to process those sentences, you need to tokenize that in order to chunk it into smaller pieces. So you can then embed that into your embedding model and then do whatever you want to do with those vector arrays. I'm not going to dive really deeply into how specifically the different chunking strategies work, but I might point you to a helpful resource from ChatGPT later on when we go back to this. Right, so here's why tokenization is important, because it basically transforms human text, so what we can read, into a format that an actual LLM can understand. So your tokenizer will break down text into smaller tokens and convert it into numbers. So these numbers are the ones that the models actually use in order to perform calculations. Because at the end, ChatGPT, Gemini, and all those AIs, they're just basically math, and they understand numbers, and at the end they talk numbers in order to process our requests. So it's not like they actually understand human text. It's basically that the human text gets converted into numbers, and then those numbers are the ones that are being processed. So that's why we need to understand why tokenization is important and how can we work with it so we can understand it. So we have an example in here. There's an input text that says, write an email apologizing to Sarah and blah, blah, blah. And then we have tokenization, which is write, and then an email, and so on. So that's a specific type of tokenization. And then each token gets an ID assigned, and then those IDs are the ones that you actually use. I will try to find, there's a tool that I've showed on previous streams where you can see how your words are being tokenized depending on the model. I'm going to try to look that when we have a small break, so I can send it to you on the chat, and then you can visualize everything. Right, and then going back to the basic word where we started, embeddings, I'm not going to read this explanation, which is basically the actual meaning, and I also included a citation in there. I'm just going to move on into this diagram. So embeddings are important because they capture semantic relationships between data points. And you can basically plot those data points into an embedding space. So if you can see in here, we have different embedding spaces. So for example, queen and king are related because they are royalty. Then we have woman and man, that's gender. And then we have programming languages with Python and Java in here. So basically, embeddings can capture semantic relationships between different data that we have in our database or on a PDF or on a .txt file, which help us, capture these relationships. So you can start thinking that maybe you can use embeddings in order to build recommendation systems or in order to match people or create just more context aware question and answer chat based applications. So for now, we just need to understand that embeddings relate to semantic relationships, and I guess that's a very straightforward definition that we can stick up to. Right. And then the real question, we talked about tokens and we also talked about embeddings. So how do they actually relate to each other? So once a text is actually tokenized, so basically chunked into smaller pieces, embeddings actually turn those tokens into numerical representations called vectors. And then in here, we have a direct example. The word king might be represented as, and then we have the vector. And then we also have a diagram in here. We have a text, bovine bodies say, then that passes through an embedding model, and then we get the text as vector. So basically, these texts will be divided into a vector that's composed of different numbers. If you can see a vector in Python or on any programming language, like an array or so on, it contains different elements that you have in your vectors. So just as in direct a programming language, a vector basically contains these different sets of numbers that is actually our embeddings. So there's different types of embeddings. I'm not gonna dive really deeply into this because that's not the point of the stream, but just for you to know that there's different types of embeddings that exist out there. The most common ones are the contextual ones because the word spectre changed based on the sentence it is in. But again, I'm not going to dive very deeply on the different types of embeddings, but just keep in mind that it's not just one embedding. There's different types of embeddings if you would like to see it like that. And then in here, we have another diagram that represents embeddings. So basically, you have how much of a sandwich are these food items and how much of a dessert the food items are, and also their liquidness. So you can see that if embedding for pizza gets processed, it's going to be mapped near the sandwichness scale just before the hot dog, because a hot dog is more of a sandwich than a pizza, and then a shawarma, it's more of a sandwich than a hot dog. So it's just a scale on how embeddings relate each other depending on the scale that they are on. And then for dessertness, we have the apple strudel, which is also kind of a sandwich. So that's why it's also on that scale in there. So as you can see, and going back to our initial example, embeddings basically represent the semantic meaning of a sentence or a word that you want to relate something in. So you will always, when you always talk about embeddings, you always talk about relationship between things and context, context awareness in space. Right. So then there's different applications of embeddings. You can have a semantic search, which is basically just searching for something and getting results that are more accurate to what you actually asked for. Then you can also have recommendation systems, and you can also have multimodal applications. So for today, we're going to be focusing on doing semantic search, but semantic search is actually very similar to a recommendation system. And then in here, we have another picture of how there are different clusters and how the different embeddings plot each other, and they form like these really nice clusters in here. All right, so now we're going to dive into some basic math really quickly. So as I was mentioned, vector embeddings are actually related to vectors, but it's not actually yes, they have to do with our definition of physical vector in math, but they also have to do a lot into vector in a programming language languages such as Python, because at the end, a vector is just a data structure that contains different elements, and those different elements are the embeddings that we basically generated with our embedding model. And then another important thing, and then going back into, let's see, this diagram on how to classify each food item depending on the relationship with the other ones. So the reason how we calculate that relationship, there's a formula behind that, which is this formula over here, cosine similarity. There's different formulas that you can use in order to measure similarity between two vectors, but I always like to focus on cosine similarity. It's the most common one that you would see on RAG-based applications, and it's basically this small formula in here. It calculates the cosine of the angle between two vectors, which represent their direction in multidimensional space. It's a really long definition, but you don't have to memorize this formula because most of the libraries already have these function written in for you. So you only need to just call it or select the relationship model that you want to use. At the end, this is just a formula that it's being used in order to measure the similarity between two vectors. So you can actually classify it and plot it into the space. So you can have your clusters of different related items. Right, so here is a QR code in case you want to visit this example in here. So this example, it basically shows how to create your own embeddings so you can actually, visualize them. I can actually visit that super quick, see if I already have something running in there so we can all see it. And then everything that we're doing can make a bit more sense to you before actually jumping into more complex scenarios. Let me just check. Okay, so let me remove this one and add my other screen. Right, so if you go ahead and visit the QR code or this short link, which is this one, you should be able to see these code in here. I'm installing sentence transformers, then importing a Hugging Face, and then I'm calling this embedding model, and then I'm plotting two sentences. So I want to convert these two sentences into embeddings. And then finally, I'm printing those embeddings in here. So if you see in here, I have a total of two vectors. So the first vector corresponds to vanilla ice cream. So this vector goes all the way from here to here. And then the second one goes from here all the way to the end. So this second vector corresponds to chocolate pizza. So there's two in there. And then if I add more, it will generate just another vector, which we can see is just different numbers, which are my embeddings over here. And yeah, if I add more, then I will generate just more vectors. And then in order to calculate the similarity between these two sentences, I will then need to apply cosine similarity, which is a formula that we saw just earlier on our slides presentation. So yeah, at the end, it's just, this is my embedding model that I'm using. There's different embedding models that you can use. This is just one, and they have different vector dimensions. And yeah, and then it will just generate those numbers for you. Right, so that's just example that I shared on screen, but you can also feel free to visit it, run the code, or change the words that are in there to see how the vector varies and how the numbers start changing. All right, so now that we understand what embeddings are and how they work as a whole with the embedding models, we're going to move on to RAG systems, which is just basically applying everything that we've learned in a very structured pipeline that is very common nowadays. All right, so this is just a definition that I got from Geeks for Geeks, which is a really nice blog that I really love to read and also learn from. Let me see. I think this definition is a bit confusing. So let's just move on to a diagram. So RAG in simple terms is basically giving your chatbot a brain to search knowledge from, or a library of information to look from. So you can see it as giving access to your LLM to read your database, but not just passing your whole database as a text, but actually giving some meaning into that. So converting that into embeddings and calculating a score so you can get the best results possible. So the pipeline for a RAG, how it works, you have your user and the user will ask a query. Then you'll have your retriever, and then that retriever will go ahead and search into your data source, return that relevant text, and then pass those relevant texts into an LLM in order to generate a response for you. So that's how the pipeline works. We can move on to a more RAG structure pipeline in here, which is just the same pipeline. You have your user, the user will input a prompt, then you will have the retriever, which is the R. And then for the augmented, you will mix your prompt plus the context that you recently fetched from the database or whatever you're storing your data. And then you're going to pass on those two parameters, the prompt and the context, into your LLM in order to produce a response to the user. And then in here, you have each meaning of the RAG. So R is look up this external source to retrieve the relevant information. A, it's add the retrieved information to the user prompt. And G, use the LLM to generate a response to user prompt with the context. So that's what retrieval augmented generation means, which is RAG. Just basically, your user will do a prompt, and then that will go back to your database, and then you will return a prompt plus context into the LLM in order to give an answer to your user. All right, so now giving a bit more of context on how to actually connect this RAG chatbot with what we want to do. So it's like basically connecting your chatbot to a knowledge base, like a PDF, and now the chatbot will answer in context with the PDF we uploaded. But instead of just passing like all the text, the raw text to your prompt, you're actually passing only the relevant pieces of information that the user wants instead of just searching everything against everything. So for today, we're gonna be using two libraries. So we're gonna be they're mostly we're gonna be using those two libraries, but they're also applications that we're going to be using. So for Gemini, we're going to be using the LLM in order to craft our responses. And then for MongoDB, we're going to be using it as a vector database to store the knowledge. And then we're also going to be using the Voyage AI in order to plug it into MongoDB to make our requests. I'm going to be explaining a bit more on Voyage AI later on. But for now, I want us to really understand the process that is followed by RAG, and then we will move on in order to build our own pipeline. So the direct process that follows a RAG is the number one, you ask your chatbot a question. So for example, what is my favorite hackathon? And then the step number two will be that your RAG will start the action and scan the whole PDF that we uploaded to match the question that we just did. And then with the most relevant information retrieved, the RAG will hand that information to an LLM. And then at the end, the LLM will use the factual information in order to generate a response for us. So it's basically like plugging in that PDF into your chat, and then it will, respond with context on what you basically uploaded into that PDF. And then if you want to see a bit more of the technical steps, so you will need to do some query understanding. So basically breaking down the user's question into tokens, which is what we just basically reviewed, and analyzing the semantic meaning. And then after that, you will do the retrieval from the knowledge base. So basically the RAG interaction with a database, like for example, MongoDB. And then MongoDB will not actually store text, but it will actually store the mathematical representation of the information, which is called vectors, which is basically what we just saw earlier. And then the RAG will generate a similar vector for the user's query matching, and the answer is going to be enhanced with an LLM retrieved. It can be any model like OpenAI, Gemini, or DeepSeek as well. All right, so those are the technical steps that are used on a RAG pipeline. Feel free to review them a bit slowly. because when we're going to be building our app, I'm going to be explaining each of these steps just very slowly, so we can see, every section of the code and how it actually relates itself to what we're doing. Right, so here is a complete pipeline. It's more technical to the other definitions that we've seen. So we have a question which is broken down into tokens, which are basically small chunks of data, as we previously saw. And then we have our embedding model, which is turning words into a numerical representation. And then at the end, we have the similarity search, which is basically find numbers that are similar to each other. And then we have a complete pipeline here. We have the user. The user will ask a question, then that will be passing to an embedding model. That embedding model is the one that we saw on the code example earlier. Again, it can be any embedding model from any company. Then it will generate a dense vector, and it will perform similarity search against other vectors. And those vectors are going to be fetched from a database, which in this case is going to be MongoDB. And then once we fetch those important elements, we're going to pass that into a prompt. And then that's going to go into an LLM and to enhance everything for a response. And then it's going to produce an output, which is actually what the user wants with their context-aware answer. So this is a whole pipeline that goes into what we're doing, but instead of using, I think there it's Elasticsearch. Instead of using Elasticsearch, we're going to be using MongoDB as our database because it also supports vector embeddings. I really like this diagram. I think it basically summarizes everything. So that's just a complete RAG pipeline that you have in front of you in there. Right, and then as I was saying, this is just an embedding model that you can visit. We're not going to be using this one. We're going to be using the one from Voyage AI. But just for you to know that there's different embedding models that you can use. Most of them are hosted on Hugging Face, and they are completely free for you to use. But there's also other ones that are from Gemini. Gemini also has embedding models, OpenAI as well. Most or all AI companies, they have their own embedding models that you can use. So that's just something that you can keep in mind. Let me see if I can find that tokenizer so you can also see it. Let me see. Okay, I think I found it. Yep, okay, I found the AI tokenizer. So let me share that one. So as I was saying, every text can be converted into tokens, and then those tokens are the ones that are converted into embeddings. So in here, I'm using a GPT-5 to convert this, and we can type a sentence, and we can see how many tokens are derived from this sentence. So this sentence has a total of 6 tokens. We can see the tokens in here. But we can also see the token IDs, as I was mentioned. So these are the token IDs corresponding to each, chunk that I have in here. And if I add more, then the amount of tokens is going to be increasing. So if you remember, or if you have seen, the way that the LLMs charge you is per the amount of tokens that you're using. So for example, if I were to use a GPT-5 and I input this sentence that is equal to 10 tokens, it will charge me the amount per token that I have in here, depending on each model. So then you will need to go to the AI tool pricing in order to check how much it's going to charge you. There's some AI models that are free, which we're going to be using today. So there's no need for you to input any credit card information or anything. It's just, it's just going to be completely on the free tier. Right. I'm also going to drop this one in the chat in case you want to play around with that one in there. Right. So let's move along. All right, so raw vectors. We already talked about vectors and embeddings, but how do they look like? As I was mentioning, not in this example directly, but this is an embedding model that has 768 dimensions. And in order to visualize those dimensions, you solve it with math using something that's called PCA. principal component analysis. We're not going to be doing that, but just for you to keep in mind that the way that we can actually plot that into a graph is using math operations. So you can actually visualize those small clusters that are in there because they have many dimensions in there. Right, I'm also going to be skipping this one and jumping into Voyage AI so we can move on and start building with this super cool tool. So Voyage AI, it's basically a recent alliance that has grown within MongoDB. So MongoDB is basically a subsidiary that provides state-of-the-art AI models, which is Voyage AI. And it produces two things. You can either have text embeddings and re-rankers. So Voyage AI basically exposes these models via simple API endpoints that you can integrate with either vector stores, LLMs, and RAG pipelines, and existing search infrastructure. So I'm gonna go into where you can see these documentation for the Voyage AI for the endpoints. So let me send these over here with you, and then I'm also going to stop sharing this one and show you the other one. So this is basically the API that I was talking about, where you can use different endpoints that they have in here, which is super simple to use some of their AI features. So let's say that you want to create text embeddings, which is basically what we've been talking all along. And then you have everything in here. So you have your input, which is going to be a string, which is going to be an array of strings, singles text string, or a list of text strings to be embedding. So for example, I like cats, I also like dogs, and so on. Then it also has a maximum list length depending on the model that you're going to be using. They have different rate limits that you can use. Then it's also going to pass on the model. So the model that you want to use from Voyage, it can be Voyage for large, Voyage for, and so on. And then the input type. So this is basically to optimize embeddings for semantic search and retrieval tasks. Then it also has a truncation, which is a Boolean whether to truncate input text that exceed the context length. We usually want to do these as true, which is default in here. And then the output dimension. So depending the output dimension of your model, and there are different values in here, which are the dimensions of the vectors. And yeah, I guess it also has encoding format, and then if you want to see the type of responses. We can also see some request examples in here if we zoom in. So input string, the model, the input type, truncation, the output dimension, coding format, and output D type. And then we can also see the response example. So we can see the object, and then we can see the embedding being generated over here, and then how many tokens you actually use on this one. So if we remember, the tokens are being generated using tools like this one. So you can see how many tokens are being generated from your paragraph in there. And yeah, those are some of the examples. And then it has everything. You can also create contextualized chunk embeddings, multimodal embeddings, or re-rank documents. So we're going to go right now into understanding what re-ranking is, which is also something very important for RAG before moving on to our example. So for re-ranking, and we already saw how to generate text embeddings with the Voyage AI API that was just recently launched with the re-ranking API, actually using a Voyage AI. So let's move on. This is just a general pipeline on why this recent tool that MongoDB launched is very helpful. So before you would have needed to connect many things on your environment, and right now you can basically centralize everything using these tools that MongoDB has prepared for you, such as managing unstructured data, having your embedding models, vector searches, and re-rankers just in a single API. And then you can just connect all of those tools with your LLM and actually get a contextually rich, grounded response for your chatbot or whatever application of your RAG you want to have in there. Right, so I mentioned quite a bit what a re-ranker is. So re-ranker is also an important term where we talk about when we're talking about RAG. So a re-ranker is basically It's models that take a query plus a list of candidate documents and output relevance scores. So these relevance scores are the ones that actually go to the users. So it will be rank your initial search results and select the most relevant candidates documents for context on the LLM. So you can see this as basically you making a search and then you get a lot of results on that search, and your ranker model will take all of those output searches and give you the most relevant ones depending on the score. So basically, ranker, it's basically ranking your outputs. You can just see it like that. It's just as simple as it sounds. It's basically ranking your outputs. And it's an extra model. It's an extra model that you want to use in order to rank those documents so you can have a more grounded RAG response in there. Then we also have a question: is Voyage AI free to use? Yes, it's free to use, but it has some rate limiting that we're gonna see. In a second, but yeah, it's free to use. You don't need to input your credit card information or anything. I mean, you can if you want, so you cannot have like that rate limit, but I recommend you not to do so, just to be more cautious on that as well. All right, so now we're gonna move on to our example. So let me remove this one and share my other screen. So right now, what we're gonna do is that we're gonna go into MongoDB directly, and we're gonna explore these AI tools that MongoDB has for us. So please go ahead, and you can actually access MongoDB from there, mlh.link/MongoDB, and I can also go ahead and look that for you. So it will direct you to this page, and you can either sign in with GitHub, so you can get $200 of benefits, either with the GitHub Student Developer Pack, or also if you already have a MongoDB account, just make sure that you log in into that one. Again, this is only if you are already part of the GitHub Student Developer Pack. If you're not, no worries. Creating a MongoDB account is completely free, and it's gonna allow you to create a free cluster without the need of buying anything and so on. So once that you are in there, you can either sign in. I'm just gonna sign in into my account so you can see everything. Why it's not letting me? That is interesting. Okay, I think I was already signed in, so I'm just gonna wait for you to sign in into MongoDB, so you should see something very similar like that. Right, I'm gonna give you about 5 minutes for you to create a MongoDB Atlas account so you can be on the same page as I am, and then we can go and explore the different sections of the dashboard that I wanted you to see in order for you to continue with the AI services that MongoDB has for us. Right, so I'll be back in about 3 minutes. Please create your MongoDB accounts in the meantime. All right, so I'm back. Hopefully, you were able to create your MongoDB account so you can be exactly on the same dashboard that I'm right now. Probably, if you're not seeing exactly the same dashboard, you still need to create a cluster. So just make sure that you create that cluster and then select your region, and then it's completely free to create your first cluster on MongoDB. So the next thing that we're gonna do, instead of going directly and connecting MongoDB first, we're gonna go into the different services that they have in here. So on the lateral left sidebar, you would see the AI models in here. So if I would go in here, it's probably gonna be empty for you, but you can create a new model API key. We can also generate this later directly from Voyage AI, but you can also just do it from MongoDB specifically. And then you can also see your usage of how you used that specific API key and your rate limits. As I mentioned, Voyage has specific rate limits, and it is also free, but then you can also only have like 3 requests per minute for these specific models that are showcased in here. Then if you want to dive a bit more into Voyage AI, I can also share with you this one over here so you can see how Voyage AI works. So they're basically linked. So MongoDB is basically linked with Voyage AI, and then Voyage AI is doing all of the embeddings generation for us, and now that is actually included here with MongoDB. That's why these models are not from MongoDB. These are actually part of Voyage AI, which is the one that I'm showing right now on screen. And then if you go in here, you can also see the different usage costs. You can see different the projects that you have, general information, your rate limits, and so on. And it will show you exactly the same models and the same token limits or request limits as well. So for today, we're going to be using some of the examples that MongoDB has for us. So I'm going to go back in here onto the Voyage AI Quick Start. And I'm going to go ahead and share this with you so we can start following along on this example. I was also going to show you the more complete example for Bragg, which is this one. But then I realized that the rate limit is really intense. So we're just going to stick to the simple example of a RAG, building a basic RAG application in here. Okay, I thought I was going to sneeze, but then it just went away. Okay, I think it just went away. That was weird. All right, so we're gonna stick into this building a basic RAG application, and this is gonna be the flow that we're gonna be using. We're going to be using MongoDB and we're going to be using Gemini in order to generate our LLM responses. So if you are already exploring the documentation, you will realize that this one is actually using OpenAI. So if I scroll down over here on building a basic RAG application, it says RAG applications require access to an LLM. This tutorial provides examples using either Anthropic or OpenAI, but you can use any LLM provider of your choice. In this case, we're not going to be using Anthropic or OpenAI. We're going to be using Gemini as our LLM in here. So this is what we're going to do. We're going to get a data source. We're going to use our embedding model from Voyage AI. We're going to create our vector embeddings. We're going to have our prompt, and then that's going to go back into the LLM, and it's going to provide a context-aware response from our information. So in here, you can select your LLM provider. Again, it doesn't matter which one you use because at the end, we're going to be using a Gemini. So there's no need for you to install these or do this because we're going to be using Gemini API keys. And then we just need to build our application. They're already giving us the code, but there's some things that we need to change in here in order to make it work with Gemini. And then we also want to adapt it so it can, generate us a bit more questions and also understand the code as well. So before copying these into VS Code, we're going to set up our project. So let me just open a new window for you. Let me keep this over here. Right, so let me stop sharing this one and then share my complete screen. So there's no need of me actually switching between them. Entire screen 2, there we go. All right. Okay. Yep, there we go. I'm just gonna make this bigger so you can see everything. There we go. I'm gonna create a new folder in here. So downloads. I was actually making some tests earlier because I wanted to do a more complete RAG application, but then I was encountering some rate limiting issues. So right now we're just gonna try to do the example in here. So Voyage, I'm gonna call these simple RAG. Wait, I don't want underscores. Simple rag. And then I'm also going to post these on GitHub so you can also see the same changes that I'm actually going to be doing over here. So let me just create my BNB file and my virtual environment, and then I'll go ahead and post these on GitHub. So at least there's some files that I can use. And then I'm also going to create my git ignore. Let me just find a git ignore Python template. Python git. Wait, what's that noise? Hold on. Okay. Right. So I'm just gonna search for a Python git ignore template so I can use that. So I can use that for my EMB file once I post it on GitHub. Okay, maybe this one should do. Yep. I'm just gonna copy paste this one and add it into my code in here. So new file dot that's not a dot git ignore. There we go. And then I'm just gonna paste all in here. That's great. I'm gonna create my .env file, and then in here I'm just gonna add all of the keys that I'm gonna be using, which are gonna be a total of 2 keys, if I'm not mistaken. Let me go into my example. It's not this one. This one. So this one uses documents. Okay, this one is not storing information in MongoDB, if I'm not mistaken. Yeah, this one's is not storing the information in MongoDB, but it's actually creating the search in here with the Voyage key, which is actually what we care about. And then we can also explore the other RAG example over here. And this one actually stores information, vector storage on MongoDB, or also it can be in memory. So this is a more complete example. We can also follow along with this one once we finish the quick start guide over here. So we already created our Atlas account. We're going to generate our API key in just a second. We're just setting up our environment for now. Let me see. Yeah, we can scroll down to this one. All right, so let me go back and then create my virtual environment. So new terminal. Then I'm going to do Control-Shift-P, create environment, and BNB. Then I want to do 3.11 BNB, skip package installation. And hopefully that's going to start creating a virtual environment for me so I can install, all of the dependencies that we're going to be needing for this quick start project. Let me plug in my computer because I'm running out of battery. There we go. Right, so let me close these so you can have more space. And then I'm going to generate a new terminal so we can see the actual virtual environment being activated. There we go. So now we're inside our virtual environment. Right, so first things first, we're going to generate our Voyage AI API key. So to do that, we're going to go back to MongoDB dashboard where we were before. It is this one. So if you don't know how to access this, just go to your lateral sidebar into AI models. And then once you click on there, you will click on create new API key. And then you're gonna just type a name. So in this case, I'm gonna call these test delete because I'm gonna delete these afterwards because I'm gonna actually be showing you the key on screen. test delete, and then this is my API key. So I'm gonna just copy this one, and then I'm gonna move that one into here. So I'm gonna call these Voyage API key equals 2, and then I'm gonna paste that one in here. And then the other one that we need to fetch is the Gemini API key, because that's the LLM that we're gonna be using. So to do that, let me point you onto how to get it. So you're gonna access this link that I'm gonna share on the chat, mlh.link/AI Studio. So this one over here, and I'm also gonna go ahead and, oops, it's not this one. Then I'm also gonna go ahead and search that for you in here, mlh.link/AI Studio. There we go. If you have used the AI Studio before, it's basically a playground where you can generate, where you can just chat with Gemini in here, and you're in the playground. You can have conversations and try different models and so on. And then you can also generate your API keys from there. So you will have to click on the Get API key in here in order to generate one. Again, this is completely free. There is no need for you to pay anything. You are going to be part of the free tier, which is also, I think it has 20 requests per day, if I'm not mistaken. So hopefully we will not surpass that amount. So I'm going to be using, I'm going to be creating a new API key. You have to click on this one, create API key. And then I'm just gonna call these Voyage delete, so I can go back later and then just delete the API key. And then you can select a project or create a new project from your AI Studio. So create key, and then I'm just gonna copy paste that, which is this one, the first one. I'm just gonna copy paste this key and then add it into my .env file. So if I go back and paste it over here, there we go. So now we have the two EMBs that we want to have, a Voyage API key and Gemini API key. We also have our git ignore. And now we can go ahead and create our main script that we're going to be using to connect all of these tools. Right, so if I go back to the example, I believe it's this one. So if I go back to the example, we can start copy pasting this code and then going step by step to rewrite the sections where we want to use Gemini. And there's, now that I'm seeing, there's also some other things that we need to change. Like, for example, the client initialization, we need to update that as well. Requires Voyage API key and OpenAI API key environment variables, which we already have. Right, so first of all, we need to install a Voyage AI, and I believe we also need to start NumPy, and I'm going to delete these because we're not going to be using OpenAI. We're going to be using Gemini. So first things first, we want to install these two. So let's go back to the docs and scroll up to see where we can install those packages. Right, so that here's the pip install upgrade Voyage AI. So let's go ahead and install that one in here. So pip install upgrade Voyage AI, and then go ahead in there. Then there's a question. I just turned to live. Just a question. API keys, if you display them, they might be misused, right? I mean, if you display them publicly. Yes, but as I said, I'm gonna delete these API keys just as I end the stream, and I don't have any credit card information attached to those API keys. So even if you try to exploit them, nothing is gonna come out of them. Because again, they're completely free to use. I mean, worst case, you will get a rate limit error, and that's just pretty much everything. Yep, so this is installing everything. In the meantime, I'm going to create the repository so you can also see it. So publish, wait, let me just give me a second and make sure that I think the .env is not part of the git ignore. Because this one is not being, I'm just gonna trust that it's gonna be in there. While this is installing, let me publish to GitHub, Voyage, simple rag. Yeah, that sounds fair. Okay. Okay, I believe maybe I did a commit with the API key, so that's gonna be a mess. Okay, hopefully it was already published into GitHub. So while this is still installing, let me go back and check if the .env was committed into the GitHub repository. So let me go to GitHub and check that quickly. Can I see the live recording later? Yes, after I end the stream, the recording it's gonna be saved onto the MLH Live YouTube page, so you can also visit from there. Right, so this is the Voyage simple rag that we just created, and let's see. Okay, so it doesn't have the .env file, but I will add a README with the uh, using let's just fill these using Voyage AI from Mongo. And then I'm gonna do example .env file, and then I'm gonna add an example of our env file, so you can have it in there in case you wanna copy paste it exactly like this, and then there we go. Commit changes. Right, so now you should be able to see the repository. I can also share this one with you. I will be updating the code that we have from the example in there, and then you also have your .env example in here in case you don't see it over here. Right, so now that that's done, let's see if our everything was installed. All right, so it looks like everything from Voyage AI already got installed. So let's go back to our main script. And yes, Voyage AI, it's already successfully installed. So now we're only pending to add the Gemini installation in here. So let's go back into our API keys dashboard from Google AI Studio. And I'm going to click in here where it says a quick start of API. That's gonna move me into the Gemini official documentation page in here. And we have a question. If someone sees your API key, they can spend your money if it's a paid service, steal your data, but private information, get you banned by using your API key. And think of like a passport if it's no longer secure. Yes, that is completely correct. As I mentioned it wasn't at the beginning of the stream, but a while ago, I'm displaying my API keys publicly, but they don't have any credit card information. And I'm just doing this for information purposes, and I'm gonna delete them afterwards the stream. So there's no need for you to worry. And yes, make sure that you always store your API keys correctly, because as this hacker mentioned, there's several things that can happen. And believe it or not, there's people that actually post their API keys that are attached to credit cards publicly, which is a huge mistake. Right, so going back into the documentation for Gemini API, we will need to install this package, and then we're also going to be following some of the steps in here in order to adapt the OpenAI code that we have for our Voyage AI example. So I'm just going to copy paste this one into here, and we're going to install that. And I'm also going to add our requirements and requirements.txt in case that you want to install everything from here. So I'm just gonna copy this package so you can have it. And then I believe you will also need this one. So Voyage AI. There we go. So now you will have these two, and I'm gonna make a commit so you can have these added requirements file. Right, so now you will have the two requirements in case you need to install like these two libraries. Right, so now we already installed Google Gen AI, so that means that we are good to go into modifying our code. So let's go back and see that example. So from the Gemini API Quick Start, let me also share this one with you in case you want to be the same page that I am right now. I don't like this example. I always like to use this one where it says pass your API key. So if we go to this one directly, it will give us a better example. So first, we're going to add this chunk of code from Google import GenAI. So from here, we're going to add that import from Google import GenAI, and then we're going to use that one over here. And then we also want to import us because then we're going to get our environment variables. So our first environment variable is going to be Voyage API key. It's going to be equal to the variable that we want to get, us dot, I believe that's get emp, and then we're going to get that API key, which is called Voyage API key. And then we're going to do the same, but for the Gemini one. So this one is going to be Gemini API key and Gemini API key. And this one, it's Voyage. So let me just change it to Voyage. There we go. So now we have the two over here. And the next thing that we're going to do is that we're going to pass it on in here. So for the client, we're going to pass on API key, and that's going to be Voyage API key. And then I'm going to delete this one, and we're going to call it Gemini client. That's going to be equal to, let's go ahead and copy this one. So GenAI.client, that's the way to go. So GenAI.client, and then we're going to pass on our API key as well, which is Gemini API key. There we go. So now we have our two clients, the Voyage AI client and the Gemini client, and we are also fetching our two API keys from there. Let me make this smaller so you can see. These are some of the sample documents that are going to be converted into embeddings. It says this quarter, our company is focused on building new products and so on. 20th century innovations, blah, blah, blah. Photosynthesis in plants converts light energy and so on. These are just some sentences that are going to be converted into embeddings. And then we have a query. What are my company's goals this quarter? This is the prompt that the user is going to be asking. We can actually change this. And then it's going to generate embeddings for documents. If you can see in here, it's using the Voyage for large model, and it's converting whatever we have from documents in here into embeddings. And then it's going to generate the embeddings, but this time for the query. And the query, as you can see, it's this one over here. So again, it's converting both the documents and the query into embeddings. And then it's going to calculate a similarity, cosine similarity, but this time it's using a dot product for the similarities. And it's going to sort by similarity using argument sort with similarities. And at the end, it's going to print the search result and also the similarity score to see how related they are between each other, those ranks. And then it's going to use the re-ranking model. As if we remember, re-ranking is just basically ranking the outputs that you got from your embedding search in there. And then finally, it's going to print those re-ranked results, using number 1, number 2, and number 3. So you can then use them. And at the end of our pipeline, we have our LLM, which is just basically using those answers with the retrieved context in this section. If you can see in here, we are passing our prompt, and then we're also passing a context, and we're also passing the query. So the context in this case, it's going to be the ranked documents that we fetch from here. And then the query, it's the same one that we are asking all the way over here. And then that's going to output a result. So instead of having OpenAI in here, we're going to change these for Gemini. And for Gemini, we need to delete these. So if we go back and see the Gemini documentation, we can see that the response is being called using client models generate content. So let's copy paste that one and replace it instead of using the OpenAI in here. So let's just paste it in here. And instead of, it is not named client, I believe we named it Gemini client. So we're just going to replace that. So it's Gemini client. And then for model, we're gonna replace this and we're gonna use Gemini 3 Flash Preview. Gemini 3 Flash Preview. And instead of having messages, I think it's called contents. So we're gonna have a contents in here, and it doesn't have any brackets or anything. So we're just gonna do contents, and then we're just gonna delete all of these, and we're gonna just pass on the prompt in here. All right, so now we're good to go. We already adapted these to use Gemini. Let me just do a commit in here so you can see these on our GitHub code. Right, I believe we are good to go. We already have everything that we're supposed to have. We are using the Voyage for large, and if we go back and see Voyage AI documentation in here, we see that Voyage for large, it has 3 requests per minute, and it has this amount of tokens per minute, I believe so. So that's the Voyage for large. And then if we actually read these warning details that are in here, it says that I have not yet added a payment method. And if I actually add a payment method, I won't have a rate limit, and I will still have my first 200 million tokens free if I add my payment method. But then after that, it's going to charge me. So I'm just going to maintain myself in the free tier, even if I am being rate limited on this thing. So let's go ahead and test this script to see the output. So let's go ahead and, oh, this is so weird. Let me just do a clear in here so we can reset my terminal. There we go. And now we're going to do Python and main.py. We're going to run that. And hopefully it won't take a long time. I mean, there's just 3 documents in here, so it should be pretty straightforward. Then after doing this, we're gonna also see the RAG example that we have in there, so we can also explore it and see. You know what? After this, I'm gonna generate a vector search on MongoDB so you can also see how that is working. Okay, looks like we have an issue. Let's go ahead and fix that. Oh, I think it's related to the API keys. No API key provided. Maybe I'm not passing that correctly. Wait, Voyage API key. Is that the same? Let me see the name. Voyage API key. Wait, it's supposed to be correctly. I think then this is not the way of calling these. Let me check what's the correct way. That should be correct. Should be. API key, Voyage API key, and then here's Voyage API key, Gemini API key. No API key, but you can set your API key code using or set the variable Voyage. You can point to the Voyage model, add it with the Voyage API key path, or set the variable. I mean, I'm already doing that. API keys can be generated. I mean, I generated my API key from MongoDB directly. I'm not sure if it wants the one from Voyage AI. I guess I can also do that. I already generated a free key from Voyage AI. So let me try with that one and see if that's a mistake. So let's try these again. Okay, no, that was not the error. Let me do another terminal in here and do Python main.py. Okay, yeah, I guess my virtual environment was just laggy. So in here, we already got our responses. If I go back to if I go back to our main script, we can see that these are the documents that were generated into embeddings. And then this was the prompt. So right now, we already got our similarity. Wait, let me scroll down. We already got our similarity score in here and our re-rank results. So our top one results is this one. This quarter, our company is focused on, and then this is the second score, and then this is the third score. And then the question is, what are my company's goals this quarter? And then for the prompt, there was an error. So let's see, object has no attribute choices. So there was an error with Gemini. Let me scroll down. Okay, I guess this is what's wrong. So this is the way for using OpenAI, but we're not using OpenAI, we're using Gemini. So let's go back to our Gemini documentation and change that. So for Gemini, you do response dot text or whatever the variable of these is called. So let's just replace that in here. So we're gonna do response. Oh wait, I deleted the. So it's just gonna be response dot text. And then let's go ahead and run it again. And hopefully I won't get the rate limit error. If not, we're just gonna have to wait another minute for us to do the generation again. All right, there it is. So we got again our re-rank results, our similarity score that got calculated between our vectors. And then hopefully now we will get a response, a nice and polished response from Gemini for the question, what are my company's goals this quarter? So the answer for that question using my simple RAG pipeline is based on the information provided, your company's goals this quarter are building new products, increasing market share, cutting costs. So now let's play around with these documents that we have in here to see how the scores and the similarity vary. So let's add something similar to the goals that we want to have on this company. So let's do, my company has the goal of producing, I'm just writing random things, producing gummy bears to increase sales. And then I'm going to add another one that says, this year we will be increasing the production of, I don't know, jelly beans and more cute packaging. Right, so now the model is gonna embed all of these documents, and we will get different re-rank results. So let's go ahead and run these again to see our outputs in here. Right, so we got better, more results in here. So this was the first one, this quarter, our company. Then the second one was my company has the goal. And then the third one was this year we will be increasing the production of. So what are my company's goals this quarter? Building new products, increasing market share, and cutting costs. So those are the company's goals this quarter. But if we change the prompt and instead of asking company's goal this quarter and just change it to company's goals, let's see how the output changes. So let's do this again. Okay, now I just got the rate limit, so I'm just gonna wait. Just gonna wait. In the meantime, I'm gonna upload these to GitHub, change document, upload. So you can see we only have 3 requests per minute or 100K tokens per minute. So we just have to wait, I guess, a minute for it to be refreshed. In the meantime, I'm going to show you this official article that MongoDB just launched. So Voyage AI MongoDB. Let me see if I can find that article. It was a really cool article. Wait a second. I think I have it in here somewhere. Okay, yeah, I just found the link. So this is the official article that MongoDB launched just last month, introducing, embedding, and re-ranking API on MongoDB Atlas. So in here, they're basically featuring the Voyage AI embedding and re-ranking models, which is basically where we were on the dashboard. Then it also shows, the importance of these tools and then how you can connect your own clusters into your API services. So you can also have your own embedding models and the re-rankers as well. And yeah, I can also share this article with you in case you want to read a bit more about the re-ranking API using Voyage AI. It's just a really new tool. So, for example, if you go to an MLH hackathon and then you want to apply for the best use of MongoDB, maybe using Voyage AI and the ranking API will actually get you that MLH prize. That's just a pro tip, using the new cool tools that are out there that you can use. Right, so let's go back in here. And let's run this again and see if the rate limit got refreshed. Okay, there we go. So we got the questions again. And then just because I deleted this quarter, now my goals are different. So now my company's goals is to produce gummy bears and increase sales. Why? Because it says my company has the goal of producing gummy bears to increase sales instead of having this quarter. So that's how you can play around with embeddings and how they actually create more grounded text responses. Again, if I go back into the official documentation here on the Voyage AI Quick Start, you can also play around with the different tutorials. There's also tutorials for doing semantic search. You can also do RAG pipelines, which is basically what we focused on today. And you can just follow along on these tutorials. They're pretty straightforward, and they have everything that you need to know for building your RAG applications. Just as a heads up, this is also my first time using the Voyage AI tool plugged in into MongoDB, but I have to admit, as a MongoDB user for quite a while, I would say this is really useful, especially because now they have this AI models section in here. And again, you can also just still go back to your regular vector search and just create your vector search for embeddings in here as well. That's another thing that you can do. Then this is really nice because they also input these small videos for you in order to, there's a quick video for an introduction to vectors and embeddings and why they matter for Atlas vector search. MongoDB is going all in on AI, and these are just some of the tools that you can use in order to, make your hackathon projects or your personal projects much, much better. All right, so I'm going to leave you with my repository in here. If I refresh, then you should be able to see the most recent code, the requirements in here in case you want to go back and also, run these by yourself so you can see all of the examples that are out there. I already shared with you pieces of information. If you want the slides, feel free to DM me on Discord so I can share with you. And yeah, let me just go back to our initial slides in there. Right, so hopefully you really enjoyed this stream and you were able to understand how embeddings work and then how MongoDB plays a very important role into creating vector index searches for us. If you really like this stream, you can drop your opinion on this link, mlh.link/global hack week feedback. Or also if you have any feedback or something you want to see at Global Hack Week, something you want to change or something you want to add, you can drop it on that Global Hack Week feedback in there. And yeah, I guess that will be everything. I believe I won't be seeing you for the next Global Hack Week, but I might be present if needed on the other one that's upcoming. Again, it was my pleasure having you. And if you have any questions or you want to get access to the Google Slides, you can DM me if you want them so I can share you the view link. And yeah, hopefully you get to build more cool projects. Keep tuned in into Global Hack Week because it's still not over. And if you didn't check in, there's a QR code at the left top corner where you can check in and get your points for the weekend. Again, thank you everyone, and I will see you until the next one.